Hello students, in this session
Let us solve a question on slope and deflection. A cantilever beam with square cross section of 6 mm side is subjected to a load of 2 kN normal to the top surface as shown in figure. The Young's modulus of the elasticity of the material is 210 GPa. The magnitude of slope at Q point we have to find out 20 mm from the fixed end. This we have to find out, right? So basically we have a cantilever beam at which 2 kN load is applied at the free end. This is the free end, and we have to find out the slope at this point. What is the slope at this point? So there is some slope at point Q. So what is the slope at this point? This we have to find out, right? So conditions are given. The cross section area is given to us 6 by 6 millimeter. The cross section area is given. So we have to find out the slope. So let us solve this problem.
we are given with a cantilever beam with point load at the free end 2 kN. The cross-section area is also given 6 by 6 millimeter square. The length of the beam is given 100 millimeter, and at 20 millimeter from the fixed end or 80 millimeter from the free end at point Q, we have to find out the slope. So this is a question of slope and deflection. We have to find out the slope at point Q. How to solve this question? Let us solve this question. We know this deflection equation. We know the deflection equation is EI d2y by dx square equal to minus m at a point x, right? This is our deflection equation, right? So let us take any section x which will be valid from P to, say this is point A for the entire beam, right? Anywhere you can take the section. Let us take here. It will be valid for Q also. Section, write this, and it will be negative. So bending moment at x will be equal to minus px, which is valid for entire section, right? This is load is suppose p, point is p and load is p, suppose, right? P is the load, suppose. So px is there, right? This load is p, basically. P is equal to 2 kN. So px, so we can put here, so ei d2y by dx square will be equal to px. We can differentiate it to get the slope, so integrate it to get the slope. So ei dy by dx, integrating it, we will get that will be equal to px square by 2. Differentiating it, integrating it, plus some constant, we will get some constant c1, right? Integrate it and then we will get the constant also. Now how to solve this question, constant c1? How to find out this c1? To find out c1, we should know the boundary condition. What is boundary condition? One of the boundary condition is that slope at this point A, slope at point A fixed end equal to 0, that is at x is equal to L. And second is the deflection at point A is 0, right? Both endpoints, the slope and deflection is 0. But this is basically slope. This is slope, right? Theta A means dy by dx. This is slope. So this is 0 at x is equal to L. So put here 0, you will get the value of c1. Put here 0 slope at x is equal to L, you will get the c1 value. So c1 will come out to be minus p L square by 2. So this is c1. Put in this equation again, and you will get the slope. So slope will come out to be d2y dy by dx will be equal to px square by 2 ei minus, this is minus, pl square upon 2 ei. This is the slope, and we have to find out the slope at point x is equal to 80 millimeter, because we are taking from the free end. We are taking from free end, so that's why we have to take 80 millimeter, not 20 millimeter, because 20 millimeter is from the fixed end. So dy by dx at point Q will be equal to, we have to take all the dimensions same. If we are taking x in millimeter, then E should be in megapascal and I should be in millimeter to the power 4. So P, what is P? Load 2 kilonewton. So 2 multiplied by 10 power 3 Newton, this become Newton. X square, X is 80 millimeter, to 80 to square taking in millimeter. 2 multiplied by E, modulus of elasticity is given to us 200 gigapascal. Convert it into megapascal so that answer may come in radians only. What is I? That is BD cube by 12. BD cube by 12. 6 into 6 cube by 12. So this will come out to be 6 multiplied by 6 cube by 12. This is I. Right? Minus P. Again P. That is 2 into 10 power 3 into L. L is length, total length, that is 100. 100 cube, 100 square, PL square by 2 multiplying 210 multiply 10 power 3 multiply BD cube by 12, that is 6 into 6 cube by 12. So this is the slope. This is the slope at point Q. Solve it and you will get in radians the value as, so theta in radians, theta at point Q or dy by dx at point Q will come out to be 0.16 radians. So this is the answer. So this is the answer of this question. We have to find out the slope, and the slope was come out to be 0.16 radians.